Hi, welcome to Parametric House. In this Grasshopper short lesson, I want to show you how this algorithm works so you can understand this step by step. Let me first turn off everything. And first we're going to start with a domain box. You can find it from the surface primitive here for the domain box. And as you can see here, this is going to be the size of x, y, and z. After defining the x, y, z, I'm going to put all of those to 5, so it's a complete box. We can use the box array from transform array box array here, and we're going to use that as the geometry and also the 3D box array cell. So it's going to be the same. That's going to make it completely array and sit on each other and make a complete box again. You can define how many you need for the x, y, and z. If I bake that, you can see that we have produced these boxes and we have the final results. Okay, after we have the boxes, what we want to do here is to define a point attractor. For the point attractor, what you can do here is to use a bounding box, which is going to be right click and union box. It's going to make a complete union box from all of the boxes. You can see it here. Then you can deconstruct it and extract the edges. So obviously it's going to give you faces, edges, and vertices. And we can use the list item to pick up these edges. As you can see here, it's going to be 8, 9, 10, and 11. So I'm going to pick up the edges. Because if I bake this, you can see I'm going to say direction. One of these are just in another direction. So what we want to do is to pick the second list item. Let me just show you here. This is the first one. This is the second one. For example, this one, not the first one. We're going to pick up the second one, and we're going to flip all the curves with this guide curve. So you can use the flip curve to flip those lines, and the guide curve is going to be the second one. So now if I bake the results and type direction, dir, you can see that both 4 of them are in one direction, which is really great because what we want to do is to loft them together. We have this loft. Why we have produced this surface is because we wanted to move the point attractor around this. So now that we have the loft surface, we can use the evaluate surface tool, surface evaluate surface. And remember to have to right click and reparameterize. Then we can give it an empty slider. And if I turn this on, you can see that I can move this point around on that cylinder. So that point is actually moving on this cylinder, as you can see here. Okay, after defining the point attractor, which is use this technique here, we're going to find the distance between the point attractor and the center of the boxes.